Okay, so question 20 says a golfer hits a shot to a green that is elevated 3 meters above the point where the ball is struck. The ball leaves the club at a speed of 14 meters per second at an angle of 40 degrees above the horizontal. It rises to its maximum height and then falls down to the green. Ignoring air resistance, find the speed of the ball just before it lands. So we start off by drawing our diagram, and our initial velocity is 14 meters per second at an angle of 40 degrees, and we know it lands 3 meters above where it was initially struck. So for our x components, using trigonometry, we find that the initial velocity in the x is 10.72, final velocity in the x is 10.72, acceleration in the x is 0 meters per second squared, and we don't know our displacement or our time. For our y components, we use trigonometry again and find the initial velocity in the y is 9 meters per second. The final velocity in the y we don't know. The acceleration in the y is negative 9.81, and the displacement is 3. At the time we don't know. So since we already have the x component of the final velocity of the ball, all we need to do is find the y component of the final velocity of the ball. So using the equation that our final velocity squared equals to our initial velocity squared plus 2 times acceleration times displacement, we plug in our y values and get that our final velocity in the y is 4.72. Then using trigonometry, we would do that our final velocity is equal to the square root of our final velocity in the x squared plus our final velocity in the y squared. This is basically the Pythagorean theorem. We use this to find the hypotenuse of a triangle. So the equation is c squared equals a squared plus b squared. So in order to find the final velocity, we would do the same thing. It's like we're solving for c. So once we plug in our values, we get that the final velocity of the ball is 11.71 meters per second.